In the presentation of a scientific problem, the other player is the good Lord. He has not only set the problem, but also has devised the rules of the game, but they are not completely known, half of them are left for you to discover or deduce. Erwin Schrödinger, physicist.
Scientists try to understand the principles that control our world. The visible everyday world of chairs, tables, and kittens belongs to classical physics, which makes definite predictions. That everyday physics assumes that nature is deterministic. As the 20th century rolled on, it became clear the many tiny atomic events that nature was built from were outside the reach of that traditional physics. In this deeper domain, another set of laws operates, but the main characteristic of this law is uncertainty, not determinism. In response to this unpredictability, a new field of physics appeared. Its toolkit is known as quantum mechanics. These discoveries, and their explanations, transformed physics over the last few decades, and will create extraordinary advances over the coming century. A quantum reality. Before quantum physics, scientists imagined atoms as tiny solar systems. They visualized electrons playing an orderly role as miniature planets in orbit around the nucleus, which was like the Sun. Gradually, they understood that the universe is much stranger than such simple models. No theory in science is a protected species. That is one side of scientific discovery that can make believers uncomfortable, as it seems, no model of the universe is ever permanent. Instead, discoveries are made by pushing a theory to its limits and seeing where it breaks. Unlike relativity, quantum physics was a joint project, with many great minds cooperating to understand the universe better. Quantum mechanics had initially been worked out in the years 1925 to 1927 by Niels Bohr and Werner Heisenberg, among others. Einstein never accepted it. He rejected it because quantum theory limited what science could learn, and it depended on random events, not determined by existing causes. Even so, quantum physics was accurate in its predictions. He had helped improve it himself when he discovered the photoelectric effect. This effect is the same process that solar panels use to make electricity. However, Einstein believed it was a temporary solution, and worked at reforming it into one part of a grander theory. He also found the way that quantum physics needs an observer, irritating and strange. "Do you believe that the moon is not there unless we are looking at it?" he once asked a colleague. Yet, as a popular song goes, the universe is made to be seen by our eyes. The observer effect and other quantum forces are essential to nature. The properties of particles only come into existence or have any fixed reality when measured. In other words, when they interact with the larger world. Before the measurement takes place, they exist only as a field of probabilities. A strange state that holds many alternative possibilities. At a tiny scale, the universe is built from probabilities of different kinds. Within atoms there are no stable parts. Unlike the plastic balls and connectors of high school chemistry that represent molecules. Richard Feynman put it this way: the behavior of things on a very tiny scale is simply different. An atom does not behave like a weight, hanging on a spring and oscillating. Nor is it like a miniature representation of the solar system, with tiny planets going around in orbits. Nor does it appear to be somewhat like a cloud, or fog of some sort, surrounding the nucleus. It behaves like nothing you have seen before. In quantum physics, a scientist's choice of what to observe changes what they can learn next. So some combinations of questions become impossible to answer because the underlying reality is fluid. Aristotle and pocket watches. Science has long ago moved on from treating nature as a mechanism. A vast Newtonian clock or orrery with gears that turn the seasons and move the planets. That is disproven by more than a century of relativity theory, quantum physics, chaos theory, and genetics, among other discoveries. However, even among scientists, the metaphor of nature being built of unfailing cogs and wheels lingered. Natural randomness is difficult for Christians. It challenges one of the most popular justifications for thinking the universe is designed and purposeful. Things with a random origin cannot have a purpose. Pocket watches, those Victorian icons of respectability and wealth, built of intricate well-ordered gears and wheels, have an obvious reason for existence that marks them as created. Clergyman William Paley was the first to use that analogy in 1802, comparing a timepiece to a piece of rock that does not seem to exist for any particular purpose. The stone might not be designed, but the watch certainly is. That is the teleological, or purpose-focused argument, for God being the creator. If each species and part of nature has a design and a function, as Aristotle believed, then a supervising creator is required. This argument is part of his philosophy, which is based on Plato's foundations. For his proposal to be accurate, nature must be static or at least predetermined. It can't have any real design if it's constantly evolving into new random forms and chaotically erasing previous ones. This creates an instant clash between the evidence and how Christians believe nature should behave. Along these lines, some scientists abandoned a cosmic designer. Instead, they developed a flawed idea that everything human is predetermined by our genes or unfolding molecules. In this view, free will or any kind of emergent higher complexity is just a useful delusion. That has not been proven but comes from the same assumptions. Some creationists blame sin for ruining God's lovely but static blueprint. They claim God must be incredibly orderly, pointing to his exact directions for building the temple and its services, its clothing, and rules, as well as harsh punishments for any deviation. His entire creation must also be meticulously planned. In their eyes, nature is a broken machine, instead of an adaptive dynamic universe. An alternative is to see God as the designer of nature's rules rather than hand-making every tiny thing. The evidence supports that view. Nature's laws are subtle yet powerful, implying a creator who does not design nature as a machine, like a human would, but speaks into existence the seeds of future ecosystems. Immature, but with an immense capacity to diversify and flourish. The principles of nature contain beauty, logic, and design. They exist to allow God's creation to evolve. However, freedom also implies the potential for devastation and evil. Evolution is not clever and cannot forecast consequences, therefore freedom breeds natural evil. God is able to redirect nature so misery and suffering are prevented. Since the fall, he has not done this in our universe, at least not always. Why did God include the tree of knowledge in the garden? Because he valued his creatures' ability to choose. When Adam and Eve sinned, God carried out their decision. They would no longer be shielded, but would face the full repercussions of their choice. They sacrificed the protection of God's children for the freedom to struggle and grieve. All of nature has suffered along with humanity. Natural laws are free of most controls and separate from God's splendor. The earth and universe we live in are the consequence of intricate rules that create planets and life. At the same time, it is fraught with lethal anarchy and ruin. A theory of everything. If God created the world, his primary concern was certainly not to make its understanding easy for us. Albert Einstein, 1954. Nature is uncertain and chaotic, from rocks and trees up to stars. It is chaotic in both the mathematical and the ordinary sense of that word. The laws of nature include the decay of natural systems and primal violence. There are stable islands of calm and order, but they rise from a sea of fire. We need to learn about this side of physics to comprehend our universe. Einstein and the new physics. Today's physicists seek a way to unite gravity and quantum physics. Combining them would create a theory that explains everything. Einstein spent the last 30 years of his life working to bring together his relativity with quantum effects. Unfortunately, his attempts failed. That was because he modeled the universe using classical laws. His mathematics should have included the randomness that exists everywhere. As a determinist, he doubted that the universe had any such freedom. He believed the probabilities were just an illusion. Underneath must be a mechanism generating the apparently random events. The idea of a clockwork universe, just like steam engines, was disappearing. He was not ready to let go of it, but his rejection was based on a gut feeling. The quantum theory produces a good deal, but hardly brings us closer to the secret of the old one, he wrote, in December 1926. I am at all events convinced that he does not play dice. In 1927, in a speech at the Fifth Solvay Conference, Einstein repeated this point. Niels Bohr, one of the founders of quantum theory, replied, "It cannot be for us to tell God how he is to run the world." Using hidden mechanisms rejected reality. In the same way, the ancients calculated complex epicycles for planetary motion. These were circles within circles, and even required backward movements, so the planets could orbit the Earth. The truth is that this universe's existence rests on chance and uncertainty. It is the exact opposite of a kingdom of mechanical precision. Our universe is not a Bach fugue, but more like the chaotic anti-harmonies of catenairs by Elliott Carter. However much we wish it to be otherwise. For Christians, our understanding of the universe affects how much we think God needs to direct natural events. Traditional Christianity saw the will of God in every event. Modern faiths recognize that creation is built on independent laws. Unifying physics on a T-shirt. Ironically, by challenging quantum physics, Einstein only succeeded in expanding it. In 1935, along with physicists Podolsky and Rosen, he proposed an idea. They would get around quantum laws using pairs of particles. Their method works like this. Generate two identical particles. Let them move away from each other. Measure their speed and position. Take only one type of reading on each one. Since they are identical, the properties of the other half of the pair will be the same. Then, combine the reading to give a complete picture of the system. By splitting the measurements, was it possible to discover everything about a particle? To break quantum laws? Could Einstein restore certainty by demonstrating that hidden information was there all along? Instead of fixing uncertainty, they had discovered quantum entanglement. Entangled particles are a single probability field. Starting with identical particles creates this unified field. Testing one particle limits what we can measure about the other. No matter how far apart they are. We cannot trick nature into revealing every property. Suppose we trying to observe everything at once. That randomizes the particles so they are no longer identical, breaking the entanglement. It was a rare example of Einstein underestimating nature's complexity. He could not undo the uncertainty built into the laws of nature. No one since that time has been able to do so. The quest began by Einstein to find a grand theory of everything continues. Following his lead, scientists may someday discover a single equation that unites all the forces in the universe. Hopefully, one small enough to print on a T-shirt. This search is ongoing, with the nature of gravity and mysteries such as dark energy being explored. Questions about space and time did not benefit from the advances of quantum physics. With the discovery of gravity waves, there has been recent progress. Astronomy, that watches the universe using gravity waves, is just getting started. Researchers can detect the collisions of neutron stars and black holes many light years away. That is due to the ripples these impacts create in spacetime, just as predicted by Einstein back in 1916. You might believe that subatomic physics is only theoretical. Yet, the knowledge provided by quantum physics is vital in modern electronics and computing. So, what are its various uses, and what does it explain that previous theories cannot? Over the last decade, quantum computing has progressed from theory to systems capable of beating regular computers. Quantum processors are known to be vastly better at some tasks than current ones. Quantum effects are also essential to physics because they allow certain kinds of radioactivity. Particles can display unexpected behavior, such as passing through barriers, like those in the nucleus. Conventional physics says they should not have enough energy to break out, yet somehow they do. This superpower is referred to as quantum tunneling because it bypasses barriers without any effort, rather than using energy to escape. This mechanism is what permits atoms within the Sun to fuse together and release atomic energy. Quantum tunneling is critical to life on Earth because it delivers precisely the right amount of energy for a stable Sun. The details are too complicated to go into here, but it comes from the basic uncertainty in particle locations built into nature, and the kinds of matter within the core of the Sun. The tunneling process itself has several peculiar features. Not only is no energy required, but the particles arrive instantly, exceeding nature's usual speed limit. This is allowed because nothing actually moves, the particles simply exist in a different position. Their location is not a real property but a probability. At the quantum level, reality is undefined. Entanglement is applied in modern computing to transmit data securely. Its role in chemistry is being actively explored. In nature, birds use it to see the Earth's magnetic field lines. That skill allows them to navigate across vast oceans. There are also hints that quantum processes in the brain are essential. It also assists astronomers in measuring gravity waves by improving detectors. A research station sits deep beneath the Antarctic surface at the South Pole. The IceCube Neutrino Observatory watches the unseen universe through the polar ice. It collects neutrino particles from events in distant galaxies. Its 86 light detector strings turn their lens towards the ground. They use the whole planet as a shield. That filters out unwanted particles, such as cosmic rays. IceCube detects explosions caused by black holes at the center of distant galaxies, searching for evidence to test unifying theories of physics. Researchers have released some early data combined with satellite observations. They reveal quantum forces altering space-time. Neutrinos record these changes as they travel. That matches the predictions of some models. If confirmed, it is a significant discovery, showing that gravity and quantum theory can be combined. Christians believe that God acts in our universe. How can that occur when every force is based on randomness? Alvin Plantinga, in his book Where the Conflict Really Lies, Science, Religion, and Naturalism, provides a possible answer. Both human beings and God can cause quantum systems to resolve into a final state. Humans, because we have free will in selecting the systems we interact with. Beyond that, God may be the ultimate universal observer. Alternatively, quantum systems are built to resolve on their own. Only one thing about our universe is certain, and that is, randomness affects everything. Perfect without a blueprint. The quantum world of the tiniest particles stretches the human imagination. Probabilities replace knowable reality. Scientists join the dance of particles, their results influenced by how and what they choose to test. Particles pop in and out of existence in empty space. That is why quantum physics is inspiring. Its effects extend from tiny particles out into the universe, even shaping the largest structures observed by astronomers. Forget medieval ideas of perfection, our Creator is nothing like a human architect. God does not construct worlds according to static plans. He creates universes with powers that cannot be fully predicted, with wildness in their laws, but protects each creation. As parents know, there is beauty even in children's messes because of their potential. Randomness in nature is a promise of original living things, all children of the Creator. This is why God gives nature the spark of natural chaos. However, in our universe, this power is out of control and feeding on decay, rather than growth.
Naturalism and the Bible. The modernist accepts more science and critical thinking in their approach to Scripture, but they lack a factual grounding for having their religious beliefs. The literalist denies so many sciences, yet they seek to have a religious faith grounded in facts, be that the facts of the Bible or the facts of nature. Aaron Adair.
Shifting beliefs about creation. Is science versus creation a vital question for believers? Does Christian faith require belief in the age of the earth, as implied in the Bible? However you answer that question, acceptance of traditional ideas about humanity being a special creation is declining, especially in the West. There is a trend against organized religion and a general increase in atheism in the Western world, but something else is happening. Public opinion takes decades, if not generations, to catch up with scientific discovery. Within the last few decades, there has been an explosion in the geographical breadth and precision of the fossil record as it describes prehistory. Counting individual molecules in a sample rock is not uncommon, providing accurate measurements. Considering this progress, there is little space for doubt about what the fossils tell us about living systems, as they were at the time of burial. Educated opinion among the general public is reflecting that trend. At one time, the shape of fossil animal bones was all paleontologists had to go on in placing a creature within the tree of life, but now that is only part of the evidence. Since the 1980s, fossil proteins, trace fossils like microscopic life, and the DNA of living descendants have helped to reconstruct the past. However, this information may not be equally shared. According to a 2005 Pew Research Center study, 70% of evangelical Christians in the U.S. think that living beings have not altered since their creation, whereas just 31% of Catholics and 32% of mainstream Protestants agree. So many are still clinging to false, Platonic views of nature. The discoveries of science are in conflict with existing creationism, which is based on pagan speculations about forms, the transmigration of souls, and how nature works. That species or kinds are unable to evolve into other forms, while a perfect world must also be static, are missing from the Bible, but are common Christian assumptions. The ability to point to significant gaps in the scientific record of history is disappearing. Discussing instead how this knowledge integrates with the Bible is the challenge Christians need to focus on, rather than trying to discredit it. It's helpful to think about where such evidence fits in the timeline of creation. As Isaac Newton wrote, Amicus Plato. Amicus Aristoteles. Magis amica verita. Or Plato is my friend, Aristotle is my friend, but my greatest friend is truth. There are fundamental principles in science that cause religious people to be distrustful. Science focuses on material forces. It is often skeptical about ancient wisdom and trusts reports of unusual events only when the evidence is convincing. It accepts material collected from the natural world as needing to speak for itself, without assumptions. Naturalism is the belief that there are no forces in the universe with a personality. Gravity does not go easy on the tired, and electrons do not fall in love with protons. Natural laws do not adjust for our convenience. It rejects the existence of any ghostly, demonic, or divine hand, guiding life forms or planets. Naturalism is helpful as a scientific assumption because it removes the otherwise messy question of motivation. It divides into an empirical side, focused on measuring the elements and events subject to natural law, and the principles, such as everything that exists is part of nature. Practically, it means science rejects explanations that require supernatural intervention to function. God is ruled out as an explanation, because no one can test his connection with the universe by building an experimental setup. At the same time, we do not have the mathematics for even weakly godlike intelligences. On the other side of the supernatural, imagine if scientists had to factor in shadowy or demonic forces altering their samples. That would greatly complicate coming to reliable conclusions. Assuming supernatural influences permits anything to happen for unknowable reasons. In contrast to other explanations of creation of the time, Genesis's main events are unique. These include the days of creation, direct communication between God and Adam and Eve, and the events surrounding the fall. The goal is to make clear God's role as the sole and all-powerful creator, and show how Abraham's line runs back to the loyal side of humanity. History is not Genesis's primary purpose. Its writing covers extended periods, with no more than a line or two, with many events treated as knowledge the reader already has. Care is required to understand Genesis within its cultural and literary background. It is impossible to reconstruct a timeline back to Eden from things such as its lists of ancestors. They were pre-existing lists, adopted by the writer, and also inconsistent in the available Bible manuscripts. Genetic evidence of humanity's development is more useful proof of the timing. For this reason, the precise year, when Adam and Eve first appeared in history must remain unknown. That must exist, between the markers of the Old Stone Age, with its simple stone tools and lack of writing, and the foundation of the first permanent settlements, which grew along with farming. Adventists and creation. How does the Seventh-day Adventist Church, to which I belong, fit into the creation versus science debate? In some ways, we have been a major reason why it is still a conflict. We are not against science in most fields, especially in the area of health. Adventists' use of both the Bible and science to dispute tradition has been one of our strengths. Academically and practically, we have worked to keep our hospitals at the frontiers of medical research. Seeking recognition for our schools and universities also started early with our medical graduates. That has helped integrate Adventist education into a mainstream position in society. We are accepted by other churches as conventionally Protestant, although with quirks. Randall Balmer, a professor of religion at Dartmouth College, described the mainstream view of Adventism this way. I think there's kind of a cultural difference and a residual suspicion because they worship on Saturday rather than Sunday. My observation is that Seventh-day Adventists are looked askance at, to some degree. It's not because of anything heretical in what they believe, but it is just kind of a cultural difference. Adventists emphasize the significance of a Sabbath rest, as the Bible teaches, which is an echo of Eden. That rest was something Jesus practiced in his years of teaching and healing. Faith in the literal truth of the Bible and the many strands of its history has encouraged us to support biblical archaeology. We highlight the essential role God's law plays in people's lives, although the law is just a signpost directing us towards safety, rather than protecting anyone directly. Our focus on the second coming is equally essential, promising a time when God's highest and most profound law will sweep death and decay away, forever. We have led out in defending against the violations of faith by governments. We believe the state should never align itself with any religion, as it did in the past. Our message has been heard, with 18 million members worldwide in 2015 and 21 million in 2021. Adventists are among the most widespread Christian denominations, with churches in 216 of the 237 countries and regions recognized by the UN. That means we must try to bring together many diverse cultures with their own explanations of God and creation. This challenge could result in a fossilization of ideas and a retreat to a fixed, Western and fundamentalist viewpoint, when faced with so much diversity. I hope that is not the way things play out. The Adventist Church sticks to a literal creation in a few real days, an initial perfect universe. That is a key part of this explanation, and an event beyond empirical study. As Seventh-day Adventist Church founder, Ellen White puts it, just how God accomplished the work of creation in 6 literal days, he has never revealed to mortals. His creative works are just as incomprehensible as his existence. Her objection to scientific views arose from her belief that they contradicted the intent of Genesis. Galileo's observation applies. If she had been born in the modern era instead of 1827, she would have seen what we see, and judged as we do, and arrived at a biblical explanation for nature's complex history. After all, science was just getting started in her era. Because we love God's word faithfully, some think that means rejecting science. Adventists sometimes find themselves standing alongside flat earthers, hired propagandists, promoting falsehoods for oil businesses, and governments hostile to freedom of thought in public discussions, especially online. That is a result of our occasional denial of whole branches of science. Like any area of internal disagreement, some topics are avoided more often than freely discussed, for fear of creating doubt, rather than growing faith. That means not even discussing any evidence that seems to contradict a simple biblical account. Even so, questions of creation's meaning and its need for salvation go to the heart of being a Christian. Science gives us an insight into the human condition, but also the Creator's vast mercy. Deciding that scientists are the enemy adds much heat and no light. Some believe that, like Paul, they should destroy arguments and every lofty opinion raised against the knowledge of God. Instead, why not follow Peter's advice, making a defense of our faith with gentleness and respect, a more Christ-like approach? Then, we will be able to better answer the challenges of this topic, including those coming from other church members. Many scientists recognize the value of a faith that sees meaning in our existence, provided it accepts the facts of history. Protestant culture is based on the one-of-a-kind authority of the Bible, beyond other books and human knowledge or traditions. We find truth in what the Bible says about creation and natural law. However, history needs to be seen through both scriptural and scientific lenses. Together, they enable us to focus on essential details that the Bible's account leaves out or only implies. I am not alone in saying that modern biology and deep time are compatible with Genesis. The BioLogos organization also claims the same thing. They support a weak agreement between the Bible and science. Theistic evolution sees the themes and moral principles in Genesis as not contradicting evolution or deep time, while permitting it in some ways. In summary, liberal views focus on individual salvation as the only reason the Bible exists. In contrast, conservatives need an accurate Bible. According to these groups, God implements the plan of salvation in the context of history. The plan to save humanity started with the creation and the fall. As God unfolds his goals throughout the Bible, it teaches where the separation from God occurred and how he will make it right. That knowledge is as much revealed truth as the New Testament accounts of Jesus' words. Liberal views are able to accept the accuracy of science because they downplay the significance of knowledge from the Bible, except as it describes an emotional and personal relationship with God. Conservatives therefore tend to discount or ignore science entirely. My proposal, Cosmic Creation, calls for a unified model supporting faith and science equally. The events in Genesis were real. They also explain the development of our universe, galaxy, the Earth, and living things over billions of years. Nothing in the Bible, including a creation week of 7 real days in Genesis chapter 1, contradicts any discovery of science. Adjusting to new evidence. Ideal answers to the difficulties raised by science do not exist. We ought to believe that faith is not certainty. It is the courage to live with uncertainty, as Jonathan Sacks puts it. Christians were not called into being to fight science, but to seek our Creator. We can declare to everyone that God is their parent. Our ability to understand creation extends beyond a narrow emphasis on biology, physics, or the importance of the most recent fossil. However, there is a growing contradiction between a literal understanding of Genesis and the evidence. Something has to give, and faith is frequently the victim. More innovative models of our origins are required to support Genesis's historical accuracy. We must do better, for new knowledge will damage faith if it is based on wrong assumptions.
Decay and universal law. According to author Annie Dillard, the world has signed a pact with the devil. It had to. It is a covenant to which everything, even every hydrogen atom, is bound. The terms are clear. If you want to live, you have to die. The world came into being with the signing of this contract. Scientists call it the second law of thermodynamics.
Nature as it works today is based on corruption, on the breaking down of the dying so life can exist. Even stars are part of this cycle of decay and rebirth. While, before the fall, each creature, every plant and cell, was protected by the presence of God, and urged toward growth and harmony. Exactly how this worked is difficult for us to understand, since our own universe's laws are so different. His guidance countered the risk of randomness turning to evil ends. Under the present laws, he chooses not to limit chaos, resulting in natural evil. He witnesses baby sparrows fall to their death, and stars consume their planets, but does not catch them. God prevents only the worst large-scale effects of chaos, so that life on Earth might go on. Energy's dark twin. Not so long ago, we used steam engines for most heavy work. Coal-powered steam was cheap and made factories and modern life possible. While useful, it was also inefficient. Engineers put much effort into increasing the pressure of early steam-filled boilers and optimizing the conversion of pressure into movement. Unfortunately, early engine designs could convert only 2% of the pressure into useful work. So, there was a strong incentive to improve designs. Nicolas Carnot, a French military engineer, developed a design in 1824 for a heat engine. Based on the known physics of the time, it seemed possible to capture all of the energy generated by the movement of gas between a heat source and a nearby cooling zone. Energy would be produced as the gas repeatedly cycled between hot and cold regions. On paper, his invention efficiently converted the entire potential energy of the heat difference into engine movement. That was obviously wrong, and he was able to extend the existing laws of physics to demonstrate that even in a machine with no moving parts, energy would still be lost. Any engine will experience many unavoidable losses in the real world, from loose pipes to wasteful fuels. For instance, modern steam engines, such as those used in power plants, can convert just half of their pressure into useful work. Between 1850 and 1860, Rudolf Clausius, a German scientist and mathematician, built on Carnot's work to predict losses for steam engines. He coined the word entropy, which he intended to sound something like energy, to represent the amount of wasted power. As the idea grew, statistical mechanics such as Boltzmann and Gibbs realized that they could measure it by examining the disorder in any energy system. They applied the idea to the molecules within gases, with great success, and went on to use this form of entropy in inventing the science of thermodynamics. Clausius and physicists in the same field realized that entropy's existence was a universal truth. Summing this up in 1865 with the statement, "The entropy of the universe tends to a maximum." Biology and decay. All systems decay, unless propped up from the outside. For example, our sun's energy drives most life on Earth and provides the external energy it requires. Life represents a tiny whirlpool in nature's vast stream of decaying energy. Entropy makes things fall, but life ingeniously rigs the game so that when they do, they often fall into place. Later in its development, entropy was used in information theory to represent losses within that field of study, and in quantum physics to represent the purity of quantum states. However, its primary role is to be energy's dark mirror, ruling the domain of loss and waste. In this form, its steady increase is known as the second law of thermodynamics. This law states that the energy wasted can only grow within a closed or sealed-up system. As astronomer Sir Arthur Eddington once said, "Don't worry if your theory does not agree with the observations, because they are probably wrong. But if your theory disagrees with the second law of thermodynamics, it is in bad trouble." It does not forbid species from adapting, as some creationists believe. Entropy is not the same thing as complexity. A biological system can be twisty with many complex steps or parts, and that can cause it to waste a great deal of energy. On the other hand, streamlined systems are usually efficient. Species can add information in the form of extra abilities or lose them. Nature may fight off losses for a while by opening up to outside sources, but the flow of energy in their bodies and the ecosystem they belong to will always be downhill. Entropy and evil. Cancer is the expression of uncontrolled entropy inside cells. For example, cancer cells fail at protein folding and suppressing unwanted genetic code. They are structurally less organized and prone to extra damage from inflammation. Cancers begin with uncontrolled cell growth, spread randomly through other organs, and develop treatment resistance by mutating. The existence of cancer, in particular, is a clear sign of the flaws in our universe and its deep history. Those points will be discussed in more detail in a later section. The forces of entropy lead everything to perish in our universe. That makes no sense, if only our planet suffers the consequences of sin. The major result of the fall is increased entropy. It is a key element of the enigma, that is natural evil.
Marie and the atom. A scientist in his laboratory is not only a technician, he is also a child placed before natural phenomena which impress him, like a legendary tale. Neither do I believe that the spirit of adventure runs any risk of disappearing in our world. If I see anything vital around me, it is precisely that spirit of adventure, which seems indestructible and is akin to curiosity. Marie Curie.
Seeking without faith. Christians differ on a wide range of issues. One thing they all agree on is that God is good. Yet nature's flaws can turn anyone away from faith in God's goodness. That is true of some scientists, such as the extraordinary Marie Curie, born Maria Sklodowska in 1867. She gave us the term radioactivity and was the first to prove its energy came from the inner structures of atoms. She was the first woman in Europe to receive a doctorate in research science, the first woman professor at the Sorbonne University, the first woman to receive a Nobel Prize, and the first person to receive 2 Nobel Prizes in distinct scientific areas. Many historians rank her as equal to Einstein in her impact on the public perception of science. She was born in eastern Poland, then a tightly controlled province of the Russian Tsarist Empire. Her father was a high school physics teacher and freethinker, while her beloved mother was a committed Catholic. Her mother was sick much of the time with tuberculosis. Marie was the youngest of 5 children but closest to her oldest sister Sophia, who was like a mother to the younger children. Marie would have been taught in school to respect the leader of Poland's oppressors, the Tsar. Polish children were instructed that as emperor and head of the Russian Orthodox Church, he was appointed by God to rule over them. Since the authorities were suppressing Polish education after uprisings against their regime, her family experienced many difficulties. Finances were stressed as her father had been demoted by his school for speaking out. He had protested because Russian authorities had eliminated all laboratory instruction from Polish high schools, a subject he loved to teach. Maria later recalled, "I easily learned mathematics and physics, as far as these sciences were taken into consideration in the school. I found in this ready help from my father, who loved science. Unhappily, he had no laboratory and could not perform experiments." A few years before her birth, her uncle had escaped to Paris to avoid deportation to Russia. That choice probably saved his life. The threat from the authorities extended through her childhood into her teens. Just belonging to a Polish student organization or speaking up put her at risk of deportation or death. To make ends meet, her father took in boarding students to earn money through tutoring. Tragic events followed this decision, as the overcrowding of their apartment led to an outbreak of typhus, spread by body lice. In this bacterial illness, infections start with a severe cough, bleeding under the skin, and if untreated, ends in delirium and death. Tragically for young Maria, her 15-year-old sister Sophia was killed by the infection, while her other family members recovered. Then the following year, her mother died from her long-term illness. According to Barbara Goldsmith's biography, her sisters' and mother's deaths had a shattering effect, driving a lifelong battle with depression and molding her religious views. Curie would never again believe in the benevolence of God, and would avoid formal religion her entire life. However, this suffering motivated her to seek out knowledge that could benefit her homeland and the world. Encouraged by her older sister, who had just completed her medical degree, to come to Paris, she migrated there, embracing the chance to do higher studies in mathematics, physics and chemistry at the famous Sorbonne University. After graduating, she married a fellow scientist Pierre Curie, and there is no doubt they fell deeply in love. Advancing science, by discovering radioactive elements with her husband, she devoted her life to understanding radioactivity and was later assisted by her daughter. She was also interested in practical applications of her discoveries. With her sister's help, she developed the first non-surgical treatment for cancer, opening a clinic in Poland. During the First World War, she turned to battlefield medicine, making battery-powered X-ray machines that could be driven up to the front lines, where surgeons were operating. Today her example is emulated by many doctors and scientists, who work selflessly for the progress of humanity, but without religious motivation. She summed up her scientific work as exploration and adventure. The element she discovered, polonium, named after her beloved Poland, thorium and radium, are vastly more radioactive than uranium. Their origin is found in the most violent and powerful astronomical events. These include supernovas and collisions between stars, which I will discuss later. On Earth, such elements are part of the crust, but also drift down in the material that hits Earth, riding in with the dust from deep space. Mysterious atomic whispers. One of the earliest discoveries the Curies made when investigating the invisible energy of radioactivity was how specific it was. There were identifying whispers of energy coming from each element, yet unaffected by any chemical process. They soon suspected that, unlike all other substances known to science, these materials were not breaking chemical bonds, but dividing their basic atomic structure. All radioactive substances are unstable, dividing irreversibly into other radioactive materials and eventually into lead. Radioactive atoms obey the law that closed systems always decay. All matter was created from energy, and to energy it may return. By revealing that atoms could break down, the Curies gave scientists an insight into creation. This decay at the heart of matter shocked physicists, since they had assumed that atoms were eternal. Their discovery set the stage for relativity by showing that matter and energy could exchange forms. Radioactive decay is independent of the material surrounding an element. The chance of decay depends only on its atomic structure, an event occurring within the atom's nucleus. It is also unaffected by temperature. In 1913, Marie Curie tested a sample by dipping it in liquid hydrogen, which is especially cold. Its emissions remained the same. More recent tests have confirmed Pierre's results with extreme precision. Radioactive atoms can lose protons from their core, transforming them into an entirely different element. This process is driven by quantum processes. Radioactivity is unpredictable at such a small scale, but there are vast numbers of atoms in even a small chunk of matter. So the decay time and the level of radioactivity can be predicted. The period scientists use to measure decay time is called a half-life. In a general sense, it is the time required for half of something to undergo a process. For example, when elements decay and transform, it is the time it takes for half of the source material to be altered. Although weak, compared to the fusion that powers the sun, radioactivity is essential to geology and life on Earth. It is needed for life because it generates heat, keeping our planet's interior liquid and moving, which brings up fresh minerals. In addition, radioactivity is part of the formation process of new worlds. Isotopes, decay and half-lives. Discussions about radioactive materials often mention isotopes. Isotopes are atoms with the same number of protons, but with different numbers of neutrons. That makes them heavier or lighter than the usual form of an element, and can also make them radioactive. Many elements have isotopes. For example, hydrogen can be altered by adding an extra neutron to make the material called deuterium. Lighter isotopes are formed by removing neutrons. Chemically, isotopes do react differently to their parent element, so they can be quite useful. The half-life of an element can be a long period of time or extremely short. For example, the element bismuth-209 has what may be the most extended half-life of any isotope, at about 20 billion trillion years. It is nearly stable atomically but not quite. Technetium-99m, one of the most common medical isotopes, used for imaging studies, has a half-life of 6 hours. In contrast, isotopes of hydrogen have the briefest existence, lasting for less than a billionth of a nanosecond. When elements with different decay rates occur together, in a single rock, comparing the proportions of the elements provides a reliable method for measuring its age. A rock with one radioactive element has a single clock. You can cross-check your results and measure a sample's age precisely when there are several. Today, the Curies are laid side by side in Francis National Mausoleum, the Pantheon, in lead-lined coffins. The reward and the price for a life spent seeking knowledge.